Welcome to math classes. In this video, let's see some more PYQ problems from JEE mains. Okay, this is part 6 of the video. Check my other playlist videos for the other PYQs and practice questions. Okay. Integration from 0 to pi by 3 of cos to the power of 4x dx is equal to alpha pi plus sorry a pi plus b square root of 3, where a and b are rational numbers, then 9a plus 8b is how much. Okay, so this problem is very simple actually. This is a very simple trigonometric integration. Cos to the power of 4 I can convert into in terms of cos square, and cos square I can cos to the cos square 2x basically I can convert, and cos square 2x I can convert into cos 4x, correct? So basically I can write cos to the power of 4x in terms of cos 4x. That's it. That is the way you should solve this problem. Okay. So cos to the power of 4x is cos square x whole square. Cos square x I can write it as 1 plus cos 2x by 2 whole square. Okay. If I expand this square, it will become 1 by 4 into 1 plus 2 cos 2x plus cos square 2x. Okay. Now cos square 2x again I will write it in the same way. So that is nothing but 1 plus cos to the power of 4x divided by 2. Okay. So cos to the power of 4x, I can write it as 1 by 4 plus 1 by 2 cos 2x plus 1 by 8 plus 1 by 8 cos to the power of 4x. Okay, I can combine this 1 by 4 and 1 by 8. So this will become as simple as this. This integration is 0 to pi by 3 of, okay, 1 by 4 plus 1 by 2 cos 2x plus 1 by 8 plus 1 by 8 cos 4x dx. Okay, this is nothing but, which is given here, 1 by 4x plus 1 by 4 sin 2x plus 1 by 8x plus 1 by 32 sin 4x. Okay, limits are 0 to pi by 3. If I apply the limits, this is what I get. Okay, which is nothing but pi by 8 plus 7 root 3 by 64. Okay, so which means very clear, my a is nothing but 1 by 8 and b is nothing but 7 by 64. Now 9a plus 8b is 2. That's the answer. Okay, so this is a very simple JEE problem. Okay, so don't think always that JEE problems are tough. Okay, half of them are actually easy. Okay, which are straightforward and simple. Don't do mistake, that's all. Okay, that's the important thing, and have faith. Okay, you may get first 5 questions which you don't know at all how to solve, but 6th question onwards probably all 6 to 25 everything you know and you can solve it. Okay, so be patient. Next, the value of integration from 0 to 1 of 2x cube minus 3x square minus x plus 1 whole to the power of 1 by 3 dx is equal to. Okay, so if you look at this problem, this is cubed root of f of x, correct? Cubed root of f of x. It is very difficult to simplify this, okay, factorize this or anything you want to do. It's not so easy, correct? So look at this. This is the definite integral problem. So first thing in definite integrals we should apply is, I always say, the powerful definite integrals formula or the King's rule, like some people call it. Okay, right? So apply this and see what happens. Okay, integration from b to a of f of x dx is nothing but integration from b to a of f of a plus b minus x dx. Okay, x should be replaced by sum of limits minus x. Okay, same thing we'll do it here. Okay, sorry. Okay, so if I substitute x equal to 1 plus 0 minus x, that is 1 minus x I should replace. So this is my given f of x. If I replace this, this will become 2 times 1 minus x whole cube minus 3 times 1 minus x whole square minus 1 minus x plus 1 whole to the power of 1 by 3. Simplify it. Okay, carefully. What you will get is minus of 2x cube minus 3x square minus x plus 1. Exactly negation of this value. That's what you get. Okay, so my integration is very simple now. I is nothing but this is what is given. Okay, which is same as minus of integration from 0 to 1 of same f of x to the power of 1 by 3, which is minus I. So I is equal to minus I, which means 2I equal to 0 or I equal to 0. Okay, so see this is a very powerful formula actually, definite integral formula. When you have nothing to do, basically no clue is there, try applying this one and see what happens actually. Okay, so and this should be the first one to do actually. Okay, this should be the first one to apply and see whether you get some clue for the integral problem. Okay, next. the value of integration from 0 to pi by 4 of x dx divided by sine to the power of 4 to x plus cos to the power of 4 to x is equal to. So we have solved some similar problems. We have sine and cos with some powers, and then we have a x term in the numerator. X, sine x, cos x can be also be present. Whenever you see that, again same thing, you apply this powerful definite integrals formula, okay, to get rid of this x basically, okay, and see the limits. Limits will become pi by 4 plus 0 minus x, correct? Then I should replace, okay, if I apply same formula, basically I will replace x with pi by 4 minus x, correct? This is my given integral, okay. I am replacing x with pi by 4 plus 0 minus x, which is pi by 4 minus x. So x is replaced with pi by 4 minus x. Because this is 2x, this will become pi by 2 minus 2x, okay. And the integral will become integration from 0 to pi by 4 of pi by 4 minus x dx divided by cos to the power of 4 2x plus sine to the power of 4 2x. The denominator is same, okay. Numerator there is a difference, correct? So I can write this as basically, okay, I can write this as I is equal to integration from 0 to pi by 4 of pi by 4 times dx by cos to the power of 4 2x plus sine to the power of 4 2x minus I, okay. Minus, if I separate minus x by this one, this is same as I, okay. So now this is very simple. 2I equal to this value, correct? 2I is pi by 4 times integration of dx by cos to the power of 4 2x plus sine to the power of 4 2x. Now I take my cos to the power of 4x out, okay, so that this will become integration from 1 plus secant to the power of 4 2x dx on the numerator, because cos to the power of 4 I am taking out from the denominator, right? It will go to the numerator, it will become secant to the power of 4 2x, and in the denominator I am left with 1 plus tan to the power of 4 2x, okay. Now if I take tan 2x as a t, secant square 2x dx is dt, correct? It will go off, but I will be left with other secant square 2x, that I am writing it as 1 plus tan square 2x secant square x, this is into secant square 2x dx divided by 1 plus tan to the power of 4 2x, okay. Now let's consider tan 2x equal to t, so 2 secant square 2x, sorry, this is 2x, 2 secant square 2x dx is dt, okay, and the limits will change. 0 to pi by 4 will change to 0 if I take it, t is 0, if I take pi by 4 it is infinity, so 0 to infinity it will become, okay. So my integration is nothing but integration of this is 2I equal to pi by 4, right? So I is pi by 8, and then I am getting 1 2 from here, okay, divided by 2 I'll get, so pi by 16, integration from 0 to infinity. Numerator will become 1 plus t square divided by 1 plus t to the power of 4 dt, okay. Now this I will rewrite this as pi by 16, integration from 0 to infinity of 1 plus 1 by t square divided by 1 by t square plus t square dt, okay. Why I am writing this, I'll just show you in the next slide, okay. If I am writing this way, okay, always whenever you find such polynomials in the numerator and denominator, right, numerator should be expressed as differentiation of denominator polynomial part, at least part of it, correct? So if I differentiate this, do I get this? No. So that means I have to change my denominator in terms of with respect to this value, okay. How? Let's see, okay. So this is integration from 0 to infinity of 1 plus t, 1 by t square divided by, I am writing 1 plus t 1 by t square plus t square minus 2 plus 2, okay. And these three terms I am writing it as t minus 1 by t whole square plus 2, okay. Now you take this one as k, let's take, okay, t minus 1 by t as k, then differentiation of that is 1 plus 1 by t square dt, okay, which is dk, correct. So now I am expressing basically numerator as differentiation of part of denominator, right? So this is the basic trick which you use when you see polynomials actually, okay, right? So that's what I do. T minus 1 by t as k, if I take 1 plus 1 by t square dt is dk, limits will change basically. If I take 0, this will become minus infinity k, and if I take infinity, k will become infinity, positive infinity only, okay. So my integration is I equal to pi by 16, integration from minus infinity to infinity, 1 by k square plus 2 dk, which is nothing but, we know this is tan inverse of k, 1 by root 2 tan inverse of k by root 2, okay. This is root 2 square, right? So pi by 16 into 1 by root 2 tan inverse of k by root 2, okay. Limits are from minus infinity to infinity. If I apply limits carefully, This will become pi by 16 square root of 2. Okay, tan inverse of infinity is pi by 2 minus of tan inverse of minus infinity minus of minus pi by 2, which is pi by 2 again. So this will become pi into pi square, right? So I can write it as pi square by 16 square root of 2, but normally we don't leave third in the denominator, so it will become square root of 2 pi square by 32. This is the answer. Okay. Hope you understand how to solve these problems. Okay, these are both the techniques we used are standard techniques. When you see sine and cos basically in the denominator and x in the numerator, you have to apply the powerful definite integral formula to separate x out of numerator. We take the x term out of the numerator. After that, this is simple. This, if you see polynomials, you have to try to put the polynomial numerator should be the differentiation of part of denominator. Okay, so that is the trick. Next, let f comma g are two functions from 0 to infinity to real. We two functions defined as f of x equal to integration from minus x to x of absolute t minus t square e to the power of minus t square dt, and g of x is equal to integration from 0 to x square of t to the power of 1 by 2 e to the power of minus t dt. Then the value of 9 times of f of square root of log 9 plus g of square root of log 9 is equal to. Okay, so you look at the expressions first. Okay, so there is the absolute t here, correct? And we don't know what is x value. Okay, if you want to based on limits you want to change it, minus x to 0 and 0 to x, we don't know what is x can be negative. So x to 0 is actually positive, and then minus x to 0 is positive, and 0 to x is negative, right? So we don't know that. Okay, nothing is given uh, the x values, correct? It is given 0 to infinity, which is positive, okay, which is known, but explicitly nothing is given. So how do you remove this modulus actually? That is difficult, one thing. And solving this integration also not so easy. Okay, even if you consider this as t, okay, it is not easy to solve this integration easily. Okay, so only thing is you look at finally what is asked. Sum f of a plus g of a is asked, correct? So how do you get that? You sum up these two, f of x plus g of x, okay, and then integration at that time, at that point also integration is not so easy. So what you can do is first you find out f dash x, g dash x, add them, f dash x plus g dash x, and then integrate them. That's easy. Okay, so if I differentiate this one, then I have to apply Newton-Leibniz formula, correct? So let's use the Newton-Leibniz theorem and solve these things. Okay, so this is the basic theorem which I use. Okay, first one is the f dash x is integration from minus x to x of absolute t minus t square e to the power of minus t square dt. Okay, I can directly apply this one and substitute the limits actually x and minus x directly. Then it will become x absolute x minus x square into e to the power of minus x square minus of minus, so it will become 2 times. Okay, the mistake you will do is you will forget differentiating this minus x actually, which is minus 1. So minus of this minus, it will become plus, so it will become 2 times. Okay, otherwise, yeah, this is minus x to x, so it will is nothing but 2 times 0 to x of absolute t minus t square into e to the power of minus t square dt. Now if I apply Newton-Leibniz formula theorem, this will become 2 times absolute x minus x square into e to the power of minus x square. Okay, this is my f dash x. Now second part, g dash x is integration from 0 to x square of t to the power of half into e to the power of minus t dt. If I apply t is x square, so it will become x square whole to the power of half is x. So x into e to the power of minus x square. Okay, and differentiation of x square, which is 2x. Okay, and minus, if I substitute 0, it will anyway become 0 because there is a t term here, it will become 0. My g dash x is nothing but this one. Okay, 2x square e to the power of minus x square. So my f dash x plus g dash x is nothing but this. If I simplify, this is 2 times absolute x into e to the power of minus x square. Okay, now if I integrate this, I get f of x plus g of x, which is this. Correct? If I substitute square root of log 9, then I get my answer, right? Integrate this one. This looks easy because there is x square term here and there is a x term here, correct? And how do I integrate? I should do from 0 to alpha. Okay, so that this will become a 0 for the lower limit. Okay, So this is nothing but integration from 0 to x because I need in terms of x finally. 2t e to the power of minus t square dt. Okay, so this is nothing but minus e to the power of minus t square. How did I get this? I took minus t square as k, then minus 2k minus 2t dt is dk. Okay, so this term will go off basically. Okay, this will become minus, and then e to the power of minus k is nothing but e to the power of minus k by divided by minus 1, right? So that way I get minus e to the power of minus t square, and the limits from 0 to x, which means applying the limits I get f of x plus g of x is minus e to the power of minus x square plus 1. Okay, if I substitute 0 I get 1 actually. Okay, minus of minus 1, which is plus 1. So this is my f of x plus g of x. Now if I replace x with the square root of log 9, square root of log 9, then x square is log 9, correct? Simple, square x square is log 9. So f of square root of log 9 plus g of square root of log 9 is nothing but minus e to the power of minus log 9, which is I can write it as log of 1 by 9. Then this will become minus 1 by 9, correct? Minus 1 by 9 plus 1. So, and then 9 times of this one, right? That's what I need. So 9 times of this one is nothing but 9 minus 1, which is 8. That's the answer. Okay, hope you understood how we derived to this expression finally. Okay, since it is difficult to integrate, okay, we want to differentiate first and then sum up and then integrate basically. Okay, so this is a very good question from JEE. This technique you should remember. Maybe some problems it is useful that you cannot integrate easily. You can you can do it like this. Okay, next. Let f is a function R2 from R to R, real to real. Okay, defined as f of x equal to x by 1 plus x to the power of 4 whole to the power of 1 by 4, and g of x is given as f of x. Then 18 times integration from 0 to square root of 2 root 5 x square g of x dx is equal to. Okay, first thing is you should find out g of x. How do you find g of x? Okay, whenever you find this recursive, right? Uh, Two things. One is simplify f of x so that f of x you can do it very easily. Second thing is for the simplification, if it is not directly possible here, okay, simplification is not possible here actually. You try what will be the next f of x, then you get a clue. Okay, so these are the two things we will do whenever you see such expression to simplify. Okay, so in this case, this is my f of x. My f of x is nothing but I have to replace x with again same full expression. So x by 1 plus x to the power of 4 whole to the power of 1 by 4 divided by 1 plus x by 1 plus x to the power of 4 whole to the power of 1 by 4 whole to the power of 4, and this complete power 1 by 4. Okay, so if you simplify this one basically completely, you simplify, this is what you get: x by 1 plus 2x x to the power of 4 whole to the power of 1 by 4. Okay, now 2 times you get 2. If you try next 3 times you get 3 actually. So my f of x is nothing but x by 1 plus 4 x to the power of 4 whole to the power of 1 by 4. This is my g of x. Okay, now I have my g of x, which is very simple. So I is nothing but 18 times of this value, 18 times of integration from 0 to square root of 2 root 5 x square into x by this 1 plus 4 x power 4 whole to the power of 1 by 4 dx. This is x cube. So it's very clear, right? If I take this one as t, then x cube dx will go off in the dt part, correct? So simple. 1 plus 4 x to the power of 4 is t to the power of 4. So my 16 x cube dx is nothing but 4 t cube dt. Okay, so limits will change. Limits will change from 0 to square root of 2 root 5. Change to, if I substitute 0 here, it will become 1. If I substitute square root of uh, 2 root 5 here, okay, then it will become 3. Okay, t to the power of 4 will become 3. Okay, 81 you will get. So which is nothing but 3. Okay, so now my integration is simple. 18 times integration from 1 to 3 of t cube dt by 40. Okay, which is nothing but 9 by 2 integration from 1 to 3 of t square dt, which is 9 by 2 t cube by 3. If I apply the limits 1 and 3, okay, what I will get is 39. That's the answer. Okay, do it carefully without mistake. It's a simple one. Okay, so you can do it yourself. Next, let y equal to f of x be a thrice differentiable. Okay, spelling mistake. Write differentiable function in -5 to 5. Let the tangents to the curve y equal to f of x at 1 comma f of 1 and 3 comma f of 3 make angles pi by 6 and pi by 4 respectively with positive x-axis. If 27 times integration from 1 to 3 of f dash of t whole square plus 1 into f double dash dt is equal to alpha plus beta square root of 3, where alpha beta are integers, the value of alpha plus beta. Most of you, by reading the question itself, you will stop it actually. Okay, so read the questions. Okay, reading the question is very important. Okay, this is very simple problem actually. Only thing is it's a written problem, that's all. There is nothing like single function is given, solve it, right? Integration of some f of x dx, solve it. It's not in that way, right? Only thing is it is written in the text, that's all. Okay, so you have y equal to f of x, which is thrice differentiable function. Okay, and in these limits, let the tangents to the curve. What is the tangent to y equal to f of x? dy by dx, which is f dash x. Okay, so tangent f dash x at this point, what will become then? If f dash x at this point will become, correct, f dash 1 and f dash 3, which is tan of pi by 6 and pi by 4. That's it, simple, right? So slope of tangents to the curve is f dash x. Now at point 1 comma f of 1, f dash 1 is equal to tan of pi by 6, which is 1 by root 3, and f dash of 3 is nothing but tan of pi by 4, which is 1. Now I have my f dash 1 and f dash 3. Now look at this one. 1, 2, 3 it is given, right? Already same. If I consider f dash t as k, okay, f dash t as k, f double dash t dt is my dk. So this expression is simple. Limits will become f dash 1 to f dash 3, which I have values already. That's all. This is the problem. Very simple. Okay, so be patient in reading the question first. Okay, so I of 27 times integration from 1 to 3 f dash of t whole square plus 1 times f double dash t dt is nothing but, here I take f dash t as k, so f double dash t dt is dk, so this part is dk, right? My integration limits will change from 1 to 3 will become, I have to substitute 1 here, correct? For 1 it is f dash of 1, for 3 it is f dash of 3, right? This is 1 by square root of 3 comma 1. Now my integration is simple, 27 times integration from 1 by square root of 3 to 1 of k square plus 1 dk, right? This is 27 times k cube by 3 plus k, limits are here, apply the limits, that's all, that's the answer basically. Okay, carefully apply and simplify. What you will get is I equal to 36 minus 10 times square root of 3. This is in the form of alpha plus beta square root 3. So my alpha is 36, beta is minus 10, alpha plus beta is 26. That's the answer. Okay, this is a very simple integration problem. Only thing is looking at the text, yeah, don't think it is a tough problem. Okay, next. Let a comma be real constant such that function defined by f of x equal to x square plus 3x plus a, x less than, for x less than or equal to 1, bx plus 2 for x greater than 1, be differentiable on R. Then the value of integration from -2 to 2 of f of x dx. Okay, so the information actually, if you should look at the multiple options which is given here actually, that is important. I missed here. All the options given here are integral values, I mean real values. Okay, so which means there is no a and b term. So how do you solve this? Because there is no, if it is a and b terms are there, it is a very simple integration, right? This integration from -2 to 2, I will break it from with 1 basically. One other pivot, I will write it in 2 integrations and then just take the value in terms of a and b, you will get, correct? But there is no a and b values in the final answer. That means we need to find out a and b values. So remember your limits, continuity and differentiability concepts. Those two, if you apply, you can find out a and b very easily. Since this is differentiable, that means it is continuous also. If it is continuous at x equal to 1, both expressions should give you same value. That is first, correct? F of x is continuous at x equal to 1. So which means x square plus 3x plus a equal to bx plus 2x equal to 1, which means you get one equation if you substitute x equal to 1, which is a minus b plus 2 equal to 0. Now this is also differentiable at x equal to 1, which means the differentiation, okay, differentiation of x square plus 3x plus a is equal to differentiation of bx plus 2 at x equal to 1. That is nothing but 2x plus 3 equal to b, or x equal to 1 if I substitute, b equal to 5. If b is 5, a is 3. Now you got your function. F of x is actually x square plus 3x plus 3 for x less than or equal to 1. And it is 5x plus 2 if it is x is greater than 1. Right? Now you have your function. Very simple integration is. This is the given integration. I am breaking it down minus 2 to 1 because you have pivoted 1, right? Less than 1, greater than 1. Right? And plus integration from 1 to 2 of the same function. So this part it is x square plus 3x plus 3, and in this part it is, in this limits it is 5x plus 2. Here are my integrations. X cube by 3 plus 3x square by 2 plus 3x limits from minus 2 to 1 plus 5x square by 2 plus 2x limits from 1 to 2. Okay, carefully do apply the limits. Okay, what the answer you will get is 17. This is the answer. Okay, so hope you understand how to do this one. Don't forget your basics, that is continuity and differentiability. Okay, they actually help you a lot. Okay. Yeah, that's all. These are the 6 problems mainly I want to take up in this video. I'll come up with more PYQs and then more problems, practice problems. Till then, keep doing maths. Thank you.